Hello and welcome, my dear students. Today we will start with a new chapter, Effects of Electric Current. Now, if I ask you, who was the first person to talk about electricity, electric current? Do you have an answer for that? Yeah, few of you might be taking some names, okay? But the first person to talk about electric current or electric charge was Thales, okay? It all started with Thales in ancient time, and these people, they got to know about electric current through some fishes which used to produce electric current. Now those fishes were called as the thunderers of Nile. These fishes were the saviors of the other marine life. Now after that there were many those who spoke about electric current, and the famous name is William Gilbert. William Gilbert was the next person to talk about electric current, but he did not give promising discussion, or he was not able to predict the properties of electric current. And later on came our famous, you might be knowing about his name, Benjamin Franklin. Later Franklin, through his experiments, he was able to predict more about electric current. So he is credited with the discovery of electric current, Benjamin Franklin. Okay, but it all started with Thales, William Gilbert, and later on Benjamin Franklin. Benjamin Franklin's kite experiment is very famous. On a thundering rainy day, he used a kite with a metallic string and a key to conduct this experiment, and whenever lightning struck that metallic kite, the string of the metallic kite, the charge could be felt on his hand with the help of the key. So this experiment proved that electric current passes, or there is a flow of charge. Okay, so what are we talking about? Flow of charge through a substance. Flow of charge through a substance means electric current. Electric current is the flow of charge through a substance, or you can say electric current is the flow of charge through a substance of particular cross-sectional area. Means what? Suppose this I consider it as a wire. Okay, a wire. A wire's cross-sectional area is this part. So the current flowing through this cross-sectional area is called as electric current. Electric current is nothing but the flow of charges. Now charges can be positive charge as well as negative charge. Charges can be positive as well as negative. Electric current is because of the flow of these both charges, positive as well as negative charge. But conventionally, to talk about electric current, we only give consideration to electrons. In the definition, we say that electric current is the flow of electrons through a conductor. Electric current is the flow of electrons through a conductor. Like that, in many ways you can define electric current. Electric current is the flow of charge through a substance. This is the best definition. Electric current is the flow of electrons. Okay. But always keep in mind that electric current is because of both the charges present in an substance. Now, all the substances, will they conduct electricity? No. Substances that conduct electricity are called as conductors, and substances that do not conduct electricity are called as non-conductors or insulators. Am I confusing you? No. A simple example I'll give. Suppose we have an object. We have a copper wire kept here. Just piece of a copper wire. Now this copper wire has atoms. It has lot of atoms. Atoms has electrons. Atoms has proton. Positively charged proton and negatively charged electron. Now when this current, or when this copper wire is placed on the table, you go and touch the copper wire, will you get a shock? No, never. Okay. This copper wire will conduct electricity until and unless there is a high potential and a low potential created. Okay. Until and unless there is potential difference, only then it will conduct electricity. For example, here the number of protons as well as electrons are same. Now to this, if I connect a cell, if I connect a cell with a positive terminal and a negative terminal. What is the positive terminal? The terminal with high potential is positive terminal. The terminal with low potential is negative terminal. To this copper wire, if I conduct a battery or a cell, this will create a potential difference. Potential difference. And because of the potential difference, now what will happen? The electrons will move from negative terminal to the positive terminal. Okay? The electrons will move from negative terminal to the positive terminal. So, in the discussion, we will take the direction of electric current in the opposite direction of flow of electrons. Electrons flow from negative to positive, but the direction of electric current is taken as opposite of that. That is from positive to negative. So, from positive, I will show the arrow. Positive to negative. This way is called as conventional electric current. Conventional flow of electric current. So that there is uniformity. Everyone will draw the circuit diagram in the same way. So that this happens, we have the term called as conventional electric current. Conventional electric current is from positive to negative. Okay. So if you are considering the flow of electrons from negative to positive, it is called as the electronic current. Okay. Just one thing you have to keep in mind is that electric current is because of the flow of charges. Charges can be positive as well as negative. To make our work easier, what did we consider? First we considered that, it is because of electrons. So we considered from negative to positive. But later on we understood that no, it is because of positive as well as negative charge. So then we all came to a conclusion that, okay, conventionally we will show it as positive to negative. Understood? So in the circuit diagrams, we will show the direction of electric current from positive to negative. After talking about electric current, now let us discuss the formulas, the units, etc. of electric current. As I told you, you have to write this definition in your book. Electric current is the flow of electrons in a conductor or the amount of charge flowing through a particular cross-sectional area is called as electric current. Okay? The amount of charge flowing through a particular cross-sectional area is called as electric current. Electric current is the amount of charge flowing through particular cross-sectional area. Cross-sectional area. This you have to write in your book. So, if you go for the formula, electric current I is the symbol, is the amount of charge, flow charge symbol is Q, and flowing through particular cross-sectional area in given time. So, Q upon T. In 1 minute, how much electric charge passed through that given cross-sectional area is nothing but the electric current. Electric current is the amount of charge flowing through particular cross-sectional area in unit time. Okay? In unit time. So, I is equal to Q upon T. This formula you have to by heart. This is very important formula. Now, let us talk about the units of electric current, units of charge and unit of time you already know. Let us discuss, always while solving sums we consider the SI unit. Okay. So, let us discuss about the units of electric current. The unit of electric current is ampere. Again, we had a talk about few scientists, but there are many more like Ohms or Coulomb or Tesla, Nicholas Tesla, Edison, Faraday, Maxwell. These all people have contributed into the study of electricity or charges. So to honor them, we have some units in their names. So this is Henry Ampere. So the unit of electric current is named in his name as ampere. Scientist is Henry Ampere. We have named the unit of electric current as ampere. Then we have the unit of charge. Unit of charge is in the name of the scientist Charles Augustin Coulomb. Okay, so the unit of charge is Coulomb. In French physicist, the name of the scientist is Charles Augustin de Coulomb. Okay, so like that the unit of charge became Coulomb. And then we have the unit of time as seconds. Okay, so unit of current ampere, unit of charge Coulomb, and unit of time second. All to give due honor to the people behind these terms. Okay, now when do you call the current flowing as 1 ampere? Very simple. Look at this formula and you can frame your definition. When is the current 1 ampere? Put 1 here, put 1 here. 1 upon 1 is 1 only, no? Now, when is the current 1 ampere? If 1 coulomb of charge flows through a particular cross-sectional area in unit time means 1 second, in unit time, then the current flowing is 1 ampere. Repeat with me. If 1 coulomb of charge flows through a particular cross-sectional area of a conductor in unit time, then the current is said to be 1 ampere. Okay, third time, are you repeating with me like we do in the class? Please say, if 1 coulomb of charge passes through particular cross-sectional area of a conductor in 1 second, then the amount of current flowing through it is called 1 ampere. Pause, write it down, the definition. Define 1 ampere. Before that you wrote define electric current. I don't like that definition of flow of electrons is called as electric current, because we know that electric current is the combined effect of positive as well as the negative charges. But it is not mentioned in your book, but as you take the subject ahead, no, in your 11th and 12th standard, that time you will get much more clear picture about these positive as well as negative charges playing a role in electric current. Okay. So, hope you have written all this definition and units. So, this formula you have to by heart. There will be some easy questions, numericals like how much current is flowing through a conductor if 50 coulomb of charge is passing through it for 5 minutes. How will you convert? How will you calculate? How much current is flowing through the conductor if 50 coulomb. So, here you will write 50 coulomb through a conductor in 5 minutes I told. So 5 minutes means we have to convert it into second. So this will be 50 coulomb. And 5 minute into second, how you will do? 5 into 60, right? 1 minute 60 seconds. So 5 minute 5 into 60. So 5 goes. 5 ones are 5 goes. 1 upon 6. 1 upon 6 means divide and see. 1 divided by 6, 0.1 6, 4 0, 6 6 36, 4 0. So you get 0.16 recurring dot ampere current. So I is equal to 0.16 ampere current. One numerical also you learnt. Is it easy? Okay. So electric current is a very interesting chapter. Provided you love the chapter, chapter will love you back. Okay. So it is very simple. These are the numericals that you have to consider. Write the question. What is the electric current flowing through the conductor if 50 coulomb charge is passed for 5 minutes? 5 minutes I said. So calculation also we did. Minutes you have to convert it into seconds and that's it. Now after talking about electric current, let us focus on potential difference and circuit diagram. Let's start with the circuit diagram. Circuit diagram is just a graphical representation of the components that we use, okay, for a circuit. For example, conducting wires we show by lines. So let's start. We will draw a circuit diagram. These are the terminals of a cell. The longer one for positive terminal, shorter one for negative terminal. Negative always let it be short. Then we have a key. If the key is closed, then we show it this way. Then we have a resistor. We will talk about resistor later. Now for the time being we will just show resistor, zigzag line as resistor R. This will be positive and the shorter one will be negative. Then we will talk about the ammeter. This is an ammeter. An ammeter will be in series, means one after the other. Okay. For the time being you understand series as one after the other. And this ammeter symbol is one circle and inside A. Ammeter is a device that will give you the value of current. It is used to record the current. So obviously it will be in amperes. So A. Okay, ammeter, A-M-M-E-T-E-R, device to measure the electric current. Now, device to measure the potential difference is called as voltmeter. Now, voltmeter will always be connected parallel to the circuit. Okay, it will be parallel. So, parallel means separate wire we need. Then we have this parallel connection. We will talk in detail about series and parallel. So for the time being you write it this way. For the next important part, that is we will show the direction of conventional current. Conventional current is always from positive terminal to the negative terminal. So show the arrow from positive goes up, comes down and this way. Okay. Now here we will show I for current. And potential difference is volt. Unit is volt. Okay. Now this means the circuit is closed. The current flows. If the circuit is open, that means there is no connection, there is no current flowing. So whenever this sign, it means the circuit is closed. This is a symbol for resistance, ammeter, and then we have the voltmeter. We have a circuit diagram. Now, there is some amount of work done to carry the charges from one potential to the other. The amount of work done to carry unit positive charge from one point or from one potential to the other potential, from one terminal to the other terminal, any word you can use, is called as potential difference. What did I say? The work done to carry unit positive charge from one end to the other end is called as potential difference. What did I say? Potential difference or PD. Potential difference is the work done to carry unit positive charge from one point to the other point or from one terminal to the other terminal in a circuit is called as potential difference. So the work done to carry unit positive charge. So here we have charge or symbol Q. Work done to carry unit positive charge from one point to the other in a circuit is called as potential difference. Write down how much will be the potential difference here. Potential difference will be work upon charge. Now therefore we will write PD is equal to W upon Q. You will see this formula given in your textbook. In 9th standard we have learnt it, but still I am revising it. According to the formula, PD is equal to potential difference equal to work upon charge. Now when you see this Q, you should remember we have already discussed about Q in the formula of current. I is equal to Q upon T. So what will be Q? Q will be IT. So if I want, I can substitute here for Q as IT. Okay, these all correlations you have to keep in mind. Now let us discuss more about this. Now I said potential difference is the amount of work done. Now to do work we need energy. Who is giving this energy? Who is supplying this energy? The energy is given by the cell. The cell is supplying the energy to do work. Okay. Now whenever this energy is supplied, this energy will produce an effect. The device will get heated. The device will get heated. No? You might have seen after a fan works for long hours, it gets heated. You can touch it and feel it. Same way, every electrical appliance here, in this case, a circuit will get heated. The resistor will get heated up. So the temperature increases. Because of the energy, the temperature increases. Now let us talk about the power, electrical power. So because of the work done, the work is because of the energy supplied from the cell, and this energy is converted into heat energy, because of which the temperature increases. Now we will talk about the power or the electrical power. Electrical power is defined as the electrical energy per unit time. Electric energy per unit time is called as electric power. So power, we will use the symbol P. Electric energy is nothing but the work done, that is W. Now when I say work done, you will remember the potential difference formula. So I'll write it. Potential difference is equal to work done to carry unit positive charge from one point to the other. No? So potential difference is W upon Q. Okay. So what will be the work done? Therefore, W is equal to, is W. The unit as well as the symbol of potential difference is V, volt. Okay. Unit is also volt. Symbol is also volt. The charge unit symbol is Q. So how much is W? W is equal to V into Q. Now this we will substitute here. So let us substitute. Electrical power is equal to V into Q upon T. Understood till here? What are we discussing? We are discussing about electric power. What is electric power? Electric power is the electrical energy consumed in unit time. Electrical energy upon time. Energy is because of work. So in place of energy I wrote work, because we know about work. Work is nothing but potential difference is equal to work upon charge. Then I wrote the symbol. The symbol of potential difference is V. Okay, so V is equal to W upon Q. How much will be W? V into Q. So in place of W I wrote V into Q and T. So how much is the power? V into Q upon T. This way you can use OR. Now I told you to remember, no? In place of Q, we know I is equal to Q upon T. So how much will be Q? Q is equal to IT. Q is equal to IT. That I will substitute here. So V into, in place of Q I will write IT, and down we have 1T. Okay, so this T and this T we get cancelled, and we have the famous formula of electrical power. P is equal to VI. When I remember in board exam, this was one favorite question. Calculate the power. Potential difference will be given, volt will be given, current will be given. Calculate the electrical power consumed. You will use the formula P is equal to VI. So you have highlighted that formula, one formula that we got, P is equal to VI. For me, I will highlight here and keep it aside. Now again we will be using this all in the next conversion. So now again I will start with the first thing. Power is work upon time. This work is nothing but energy. And I told you it is in which form of energy? Heat energy. So now I will write this in the form of heat energy. So in place of W I will write P is equal to H for heat energy, upon T. So how much is the heat energy? Therefore, heat energy, heat I will write for your understanding, is equal to power into T. PT. Heat is equal to PT. How much is the heat energy? Power into time. Now we have one formula already derived. What is P? P is VI. So in place of P I can write VI and then this T. So now I got one formula for heat. How much heat energy is produced when you have a potential of this much volt, current, and for time you can calculate the heat energy by using the formula H is equal to VIT. Now we can play with this formula, whatever knowledge you have gained till now. That all formula you can use here and you can modify this formula. Hope you remember the Ohm's law. You remember Ohm's law? Forgot? V is equal to IR. Here I said you to remember Babita ji. Remember Babita ji, and then that formula V is equal to IR. V equal to IR. From where we got this formula? Ohm's law. Ohm said that as you increase the potential difference, the current flowing will also be increased. More potential difference, more current. Current is directly proportional to potential difference. That is nothing but the Ohm's law. And from the Ohm's law, we got this formula V is equal to IR. So now you can see a V here. We can apply Ohm's law according to Ohm's law. Now whatever I am writing, you have to write it in your book. According to Ohm's law, you get H, I'll write as it is. H is equal to, in place of V, I will substitute the Ohm's law. V equal to IR. IR. Then one more I and then T. So this will be I into I. H is equal to I square RT. Got the second form? Second form you have highlighted. Now we will go on to the third and the last form. Don't worry. Yeah. Now VIT. From here only I will start. So you have to write this again in your book. Write this formula again down and start with me. So we saw according to Ohm's law V is equal to IR. Now in place of I, suppose what will be I? V upon R will be I. V upon R is I. In place of I, now I will write this. So this will be H is equal to V, I will write as it is. In the first case we wrote in place of V IR. अभी V को ऐसे ही रखेंगे. In place of I will write V upon R. V upon R. And here we have T. So what form I got now? Now the new form formula I got. H is equal to V into V is V square upon R, and T is there up. V square upon R T. V square T upon R. Another form of heat. Okay. So we got three forms of formula to calculate the heat energy. So what question can you expect? Derive the Joule's law of heating. What is the Joule's law of heating? You have to start with the formula of electric power. Electric power is the electrical energy, that all you will start. So what are the three forms that we got? We got H is equal to I square RT. This form we got. Then the second form we got H is equal to VIT. Then we got one more form. We got H is equal to VIT. Then the third form as H is equal to V square T upon R. These three forms we got, do you remember? This all we got from formula of electrical power. The Joule's law of heating formula, H is equal to I square RT. This is easy to remember. H is equal to I square RT. H is equal to I square RT. Ohm's law is V is equal to IR. What is electric current? I is equal to Q upon T. What is potential difference? Potential difference is equal to work upon charge. W upon Q. So all these things you have to remember. We will meet for the next time in the next class. Till then, bye. Take care, students.